Right. The stone needs to choose them. Right, so what we have here, if we want to draw the picture, there is the ground, there is the wall. And there's a student projects at a speed of 19.5 at an angle of 40 degrees, and it goes up and then it goes, whoops, oh no, what is this? Yeah. See, I don't like this new feature that keeps popping up. I want to downgrade. Smash. Right, so the first question is dead easy. It's what is the horizontal, and I suppose you might as well get the vertical component here. So that's super easy for babies. What's this part here? Come on, babies. Cos 40. And then this one here will be sine, won't it?
Yeah.
This is 12.53 meters per second. Okay, part 2.
Shall we just divide two?
Draw the two diagrams to show the possible paths that the stone could take. There's two possibilities. So the first one is that it hits the wall like this.
And come down.
Yeah, well, what's the second possibility? Actually, the second possibility is that the wall is here. Because in this picture, it still hits the same point on the wall. So the wall is either very close and it hits it on the way up, or the wall is very far away and it hits it on the way down. That's why he said two diagrams. Yeah.
Do I need to explain or just...
No, just the diagrams what he wants.
Okay. It's a minute, two possible vertical commas.
Give you an idea to draw two walls.
No. I kind of had the idea.
That's
what you read
No, you're right, I know.
But I can change the velocity.
Give you a draw like changing the...
Projectiles isn't even something technically on the syllabus. So, I mean...
Whoa! Seriously?
Yeah. So, I mean...
So I asked for them.
But it's always in every exam, so, you know. But my point is projectile questions can be difficult. This is why I say you might want to avoid this mechanics one. So, have a read. And anyway, Fahad, even if you screwed it up, you only lose 2 marks. Let's see the next part. What's the two possible velocities?
The same.
Yeah, but let's calculate them. Right, so we'll look at the horizontal and the vertical, okay? So horizontally you have UVATS and vertically you have UVATS. What's the U horizontally? 14.9 and vertically? 12.53 was it? What did I write? Yeah, okay. The V horizontally and vertically you don't know. The A horizontally? 0. The A vertically? Yeah. T? Don't know, but I suppose at least you know they'll be the same. And the horizontal distance you don't know, and the vertical distance is the height, which we don't know. Oh, we do know the height. He tells us that the height is 6.5 meters for the wall.
That's cool.
Yeah, so actually, you know, when you look at this situation, you have 3 pieces of information already. So could you get the T and the V?
Yes.
We could. What formula should we use? V squared equals U squared plus 2AS. Yeah? V squared equals U squared plus 2AS. Do I need to write that down? I don't really, do I? So, you get V equals square root of U squared plus 2AS. What's the U? Yeah, and then the A and the S. So why are there 2 answers when it only looks like there's 1? Very good, because on one path it's going up and on the other path it's going down. So this is why there's 2 answers. what are the two possible times? Well, again, that's not so difficult because we just have to find t now. So what formula should we use? S, no, yes, S equals ut plus a half 8t squared. Now, why are there two answers for time? What type of equation will this be? A quadratic. So it makes sense that there's two time answers, doesn't it? So you have 6.5 equals 12.53 t minus 4.905 t squared. Is that okay? So I get two answers for t. T equals 1.83 or 0.724 seconds. They're my two times. I'm not checking if I'm getting this right as I go along, but I am. The next one is find
minimum distance from the wall.
the short distance and the ranges. Yeah. The next part is find the two ranges, this range and this range. So why are there two answers? Well, because there are two answers for time. So you have to put both answers of time in here. What formula should we use to get the S here, the horizontal S? S equals, this is for B and BI. S equals UT plus a half AT squared. What's the A? What's the, yeah, so it's just UT. Here are the two times. And what was the U horizontally?
14.9.
Right, so the first answer is 14.9 times 0.724. So you have 10.8 meters or 1.83 times 14.9 or 27.3 meters. Which is correct.
But you multiply by the time. U
UT. There's the U. And I multiply them by the times to make the two S's.
You multiply by 724.
0.724, yeah.
And multiply by
1.83, yeah. They're the two answers, yeah. Next part, second last part. What is the loss in kinetic energy when it hits the wall?
You wrote one question twice.
Did he?
Minimum or maximum?
No. It's all good. It's all good. Don't worry. I'll protect you. Right. Now, anybody got a smart idea for part 7? There is actually a smart way to do it. Determine the kinetic energy lost when the stone hits the wall. So what does that tell us is happening to the kinetic energy? It decreases. It's lost, it decreases. So what is one way you could do it?
Total energy minus potential energy?
No. Well, you could calculate the kinetic energy at the start. Do we know the speed at the start? Yeah, and we could calculate the speed at the end. And then subtract them. But there is a smarter way to do it. The lost kinetic energy is equal to the potential energy.
Really?
Yeah.
Because at the beginning, what energy did it have? Kinetic energy. And then at the end, what energy does it have? Kinetic energy plus potential energy. The energy that was lost from the kinetic was only transferred into potential. So in fact, he's just asking you for the potential energy in a very kind of fancy way. So 0.24 times G times, and what was the height? 6.5. That is 15.3 joules. Which is wrong.
You were right at that time. Beginning minus 10.
I don't know, guys. I don't know if his answer is wrong. Unless I typed it in wrong here. What's the M?
0.24,
And the G?
9.1,
And the height?
6.5 meters.
That's the potential energy at the end.
Yeah. Yeah.
So we're looking for the energy loss.
Yeah, so like, look here, guys. Look, this is my idea. Are we looking?
Yeah.
The kinetic energy at the start should equal the kinetic energy at the end plus the potential energy. Does that KJ, are we agreed with that?
Yes.
So kinetic energy at the start minus the kinetic energy at the end equals the potential energy. What's the kinetic energy at the start minus the kinetic energy at the end? That's the loss in kinetic energy. That's what he wants, isn't it? That should equal the potential energy.
I'm not sure if the energy at the end is K equals P because it just hit the wall.
Yeah?
So maybe it's stuck on the wall or something.
Oh, I see what you're saying, that it got stuck to the wall. Maybe that's... Now, does he say something like that in the question?
It hit the wall at the end.
Oh, I see. Guys, look. It's weird. Yeah. I didn't read the question carefully enough. No, actually, that's actually weird. You have to look at the next part to see what happens. Can you see in the last part it says, when the stone hits the wall, it breaks into pieces. So I think, right, this is what's happening. The English, please calculate it down. The English here is quite tricky, so I want to draw a picture of what's happening. Okay, so the series of events is as follows. The ball leaves the ground. At the beginning it has kinetic energy, so we're all happy with that. And then as it travels in the air, it gains more kinetic energy and then it loses kinetic energy. Now literally right before it hits the wall, what energy does it have? It has kinetic energy and potential energy. And then right after it hits the wall, it only has potential, you're right, because it's like, as KJ says, it sticks to the wall, it loses its speed, then it will fall down. Now, when I first read that question, I thought he was looking for the difference between the kinetic energy here and the kinetic energy here, but that's not true. He is looking for the difference in the kinetic energy here compared to the kinetic energy here. Now, what is the kinetic energy here? Zero. So, in fact, he's looking for the kinetic energy here. That's what he wants.
Which is the same with the kinetic energy there?
No. The kinetic energy plus the potential energy here at 2 is the same as the kinetic energy at 1. So he wants the kinetic energy at the start minus the potential energy. Now I got this answer previously. What was it? 15.3. So I just need the kinetic energy at the start, which is a half m. What's the m? 0.24, and the speed at the start, 19.5 squared. So that is 45.63 minus 15.3. That is 30.3 joules, which is correct now. Okay, last part. That question was weird because he said determine the kinetic energy lost by the stone when it hits the wall, which I figured, no, please listen, please. I figured he meant when he said determine the kinetic energy lost by the stone when it hits the wall compared to where it started. Whereas what he meant was, what is the kinetic energy lost by the stone just after it hits the wall? Do you understand?
Yep.
Yeah. Alright, the last part. When the stone hits the wall, it breaks into pieces which fall vertically from rest to the ground. Right, so what happens here is, when it hits the wall, how long does it take to fall? 1.25 seconds.
Yeah.
Right, so how far does it travel? Okay, UVATS. What's the U? 0. Because remember, we just said it stuck to the wall. The V, we don't know. The A minus 9.81, and the T is 1.25. So how can I get the S? What formula? S equals UT plus a half AT squared?
Yeah.
Well, what because
The S first.
no.
So S equals UT, which is 0, plus a half AT squared. So I get here minus 7.66. So this distance here is 7.66. How far above the student's hand was the ball? We said the distance was 6.5. You see, what you don't really see in the picture is actually, this is really from the student's hand.
Yeah.
So there's a little bit extra underneath. So what is that distance? Well, that would be the difference between 6.5 and 7.66, which is 1.16, which is correct. I don't think this mechanics question is awful. I think, it's just a bit difficult, but it's not awful. I think it's okay for projectiles. Right, so have we got double physics on Monday, isn't it? So in about 20 minutes I'll leave outside Sylvia's office some practice physics and maths papers you can do over the weekend. I have to print them and take a few minutes in the little slot, yeah.